In this video we're going to look at how text is represented in computer science. So first things first, character encoding. So there's two schemes for encoding characters or text as binary. You've got ASCII and you've got Unicode. Now, text encoding schemes are also used to save files, and saved files are either in binary or they're in plain text. So the first things first, ASCII. So ASCII can only accommodate the English language and some additional symbols, such as the E with the apostrophe over in French. Other encoding schemes use ASCII as a base. So the way ASCII is created is it uses 7 bits to represent characters. So that means you can have around 120 different values with letters, numbers, punctuation, and things like spaces and things like that, and where like lines end. So 128. Now the spare bit is used for error checking. So that's a parity bit, which I will cover later in my videos. But that spare bit is just to make sure things are working properly. So a parity bit is there to check that things are in the correct order. So other nations have their own ASCII inspired encodings. For example, Whiskey is used for Vietnam and all the different Vietnamese symbols. So here's an example of the ASCII table. So you can see the letter A is 65 to us. Okay, so they do have binary examples as well, because obviously decimal and hex can be converted to binary. It's just they're not all on this example table. So what you can see is that all the characters, it goes to all the capitals first there, and then the lowercase second. So that means that if you was looking at the ASCII values, then, and you put something in alphabetical order, it would do all the capitals first and all the lowercases second. It wouldn't do A then lowercase a or whatever. So sometimes I've seen previous questions in the past where it has words with, it'll say aardvark with a lowercase a, but it'll have zebra, and then you need to talk about how zebra with a capital will actually come before aardvark with a lowercase a, and that's because of the ASCII's decimal value or hex value or binary value. So you've also got extended ASCII. So extended ASCII uses that 8th bit for an extra set of letters, bringing the total up to 255 characters, which allows a few more symbols to be used. So you can see we've got some more symbols, like some of the Greek symbols, German symbols, and things like that. So the alternative encoding scheme is called Unicode. So it's based on ASCII, but it's it contains a lot more characters. So UTF-8, so UTF-8 bits is ASCII, because 8 bits is 255 characters, and then you've got 16-bit, 32-bit, and they're all backwards compatible. So UTF-32 contains 16 and 8. So this offers a very large set of characters. So we're talking about, it's got all your letters, it's got all your different languages, you'll have all your emojis, depending on which UTF is used. So that at the minute there's not an issue of running out of space. Like with ASCII, you'd have to keep deleting characters that aren't used anymore and it wouldn't make sense. Whereas Unicode, you can have essentially as many characters as you want, because 110,000 characters is a lot. That's why so many new emojis keep getting released over time. Hopefully that was useful and you have a bit of an understanding of ASCII and Unicode, and I will see you in the next video.